Right now, the biggest career trap in tech is confusing tool usage with actual knowledge. You learn how to use an interface, the interface shifts, and then suddenly you're back to square one. Memorizing prompt templates makes you productive today, but relying entirely on a brittle wrapper means you become completely obsolete the moment a new model updates its design. According to Pluralsight's data, 70 picking a popular tutorial at random is a quick path to frustration. Matching the right curriculum to your actual baseline is how you build a permanent career moat. Let's start with the first group: managers, designers, and non-technical professionals who need to understand AI but are intimidated by coding and complex math. Your definitive starting point is the Elements of AI course. It breaks down the core concepts step by step, explaining the exact difference between machine learning and how algorithms make decisions. The trade-off here is straightforward. You write zero code, you get a clear view of AI's actual limitations, but you will walk away with absolutely no ability to build or deploy a model yourself. For business leaders, stopping right here is the highest ROI decision you can make. It gives you the exact vocabulary needed to pierce through industry hype and assess real-world impact, without wasting hundreds of hours on unnecessary calculus. The second profile is the aspiring developer. You know some basic Python, and you want to deploy real-world applications immediately. Your entry point is the Google Machine Learning Crash Course. It is the premier tool on the internet for establishing a systemic view of how data actually works. This specific curriculum forces you to stop treating AI as a magic black box. You learn exactly how data collection, classification, and loss functions govern the training process. From there, you pair Harvard's CS50 AI with Hugging Face's NLP course. CS50 forces you to develop a rigorous problem-solving mindset, while Hugging Face trains you to master natural language processing, the core of today's AI ecosystem. To accelerate your deployment skills, Fast.ai offers a top-down methodology. Instead of spending months on theory, you build functioning models on day one, and then reverse engineer the theory behind them as you go. The trade-off for this tier is speed over depth. You gain rapid portfolio wins and practical deployment skills, but you sacrifice the deep mathematical intuition required to debug complex edge cases. If you need to bridge that math gap, visual learners should turn to channels like 3Blue1Brown and StatQuest. They build your visual intuition for how neurons and gradient boosting actually work, bypassing the dense equations. Combining rapid practical building with strong visual intuition is the most efficient route to employment. It transforms a standard coder into a highly employable AI-enabled developer. Finally, we reach the third profile, the deep architect. This is for the serious learner targeting a role at an elite AI lab. This path requires massive cognitive friction. You have to abandon high-level tools and wrappers to focus purely on tensor-level mathematics and core architecture. Umar Jamil's curriculum is required viewing here. You will code attention mechanisms and encoder blocks to build complete transformer architectures entirely from scratch. Then you move to Andrej Karpathy's Zero to Hero series. It stands as the absolute gold standard for ground-up neural network engineering, pushing you down to the actual tensor level. To bring those foundational skills into the modern enterprise environment, Maxime Laban's LLM roadmap covers specific deployment techniques like retrieval augmented generation, fine-tuning, and vector embeddings. The trade-off is steep. Completing this tier grants you elite engineering skills and access to top-tier AI labs, but it demands a grueling, months-long time commitment. This deep path is massive cognitive overkill for 95% of the standard tech workforce. But for the 5% who want to research and define tomorrow's foundational models, it is absolutely mandatory. Analyzing individual courses is only half the battle. The real work is selecting the exact curriculum that fits your specific context and constraints. This decision framework starts with your primary technical filter. Do you know Python? If the answer is no, you bypass the coding entirely. You take Elements of AI to build a solid foundation of AI literacy. If the answer is yes, you move to the second crucial filter. What is your end goal? Are you trying to build apps or research architecture? If you want to build apps, you follow the practical developer branch. You take Fast.ai and Maxime Laban to focus strictly on deployment and portfolio building. If you want to research architecture, you take the heavy engineering branch. You combine CS50 and Karpathy to achieve tensor-level mastery. The success of this entire process relies entirely on accurately and honestly assessing your current technical baseline before you enroll in anything. You have to actively abandon the fear of missing out. Give yourself permission to completely ignore highly advanced math courses if they don't serve your specific daily job role. Because elite education is now completely free and widely available, the primary barrier to entry is no longer financial. The barrier is pure focus. True career security in the AI era isn't achieved by trying to finish every course on the internet. You secure your future by picking the single lane that matches your trajectory and committing to it deeply.